change this into a power. I know that all radicals are powers. What power is this one?
A 1/2.
Very good. So this is the same with integral from 1 to 9, from x to 1/2 dx. What is the antiderivative of x to 1/2?
X to 3/2 over 3/2.
Exactly. I have to flip the denominator, 2/3, and x to 3/2 from 1 to 9. Please leave 2/3 alone. It can patiently wait. Plug in 9, and remember, is the denominator is 2, so I take the square root. The square root of 9 is 3, and 3 cubed is 27. Minus. The square root of 1 is 1, to the 3rd power is still 1. 27 minus 1 is 26. 26 times 2 is 52 over 3. Very easy to check. Very easy to check. Because we have this tool. Use it to check and make sure you don't have an error. Go to math, go to number 9. It pops up. It's from 1 to 9. And then we have the square root of x. Really? I didn't mean that. Yeah. Okay, so the x should pop up in there, but it's not. So this is the square root of x. And the limits of integration are called, like for the summation notation, the same thing. So from 1 to 9. When I click enter, I have to get 52 over 3. It's not going to give me 52 over 3. It's going to give me some gibberish that I can change into a fraction. This will not always happen. You will not be able to change it into a fraction, so you still have to be able to determine a definite integral by hand. Okay? Because if the answer is e, you're not going to get a fraction out of e. It's not possible. E is an irrational number. Whatever you want to do, no matter what you do, you're never going to change this into a fraction because it's not possible. So you still have to know how to determine a definite integral, please. At any point in time, when I'm asked to find a definite integral, I will always have to ask myself, is this function continuous from 1 to 9? Yes or no? Yes, it's continuous. Otherwise, I cannot use the fundamental theorem of calculus to determine this. I cannot. Okay, page 10. Let's choose another. So that was one with rational exponents. We looked at examples with all rational exponents will be treated in the same way. We looked at polynomials, we looked at rational exponents. I would like to look at 32 now. Is this function, it's from 0 to 4, I think. Oh, I'm looking at something else. From 1. From 1 to 3. From 1 over x squared plus 1 over x cubed dx. I changed the z into x. So, is this function continuous on 1, 3? If it is not continuous on 1, 3, I will say FTC, fundamental theorem of calculus, not applicable. But the function is undefined at 0 only, and 0 is not here. So the function is continuous, so I cannot write this. Because fundamental theorem of calculus is applicable. I just have to determine what it is. For this one, we have a formula. which function prime, when I differentiate, I get 1 over x squared. Please remember this is very
To the
negative
first.
1 over x. This is a formula that we discussed. 1 over x prime is negative 1 over x squared. And if I have positive 1 over x squared, then this is negative 1 over x. This is something we discussed a long time ago when we started derivatives, and I said, please remember this is a very important formula. So when I differentiate negative 1 over x, I get 1 over x squared. Now for this one, yes, I have no choice. 1 over x cubed is x to negative 3, correct. But not for this one, because we have the formula. So, plus. So I need to find the function whose derivative is this. It doesn't matter, the power doesn't matter. I still have to add 1 to it and divide by the result. No matter what the power is, a fraction, positive, negative, it doesn't matter. So what do I write? Which function prime is x to negative 3?
X to the negative second.
Over negative 2. Awesome. That's it. Great job. So I will rearrange it. Negative 1 over x minus 1 over 2x squared from 1 to 3. Negative 1 over x is negative 1 over x. Then the negative 2 in the denominator changes the sign in front. And x to negative 2 goes to the denominator. Now I will plug in 3. When I plug in 3, negative 1/3, negative 1 over 9 times 2. Minus, parentheses, always, so you don't forget to distribute the negative sign. When I plug in 1, I get negative 1. When I plug in 1, I get negative 1/2. This is ugly to work with, but we have no choice. So, negative 1/3, 1 minus 1 over 18, plus 1 plus 1/2. The least common denominator is 18. This one needs a 6. This one needs an 18. And this one needs a 9. Negative 6 minus 1 plus 18 plus 9. Do not try to simplify. That would be terrible. So 9 minus 7 is 2. So I have 20 over 18. And I will simplify by 2, and I get 10/9. I can check, of course. Okay. So I have the integral from, so math, 9 from 1 to 3. And then I have 1 over x squared. For me, it's more difficult to plug this in than to do the work, to be honest. 1 divided by x to the 3rd. And of course, dx. Dx should pop up. They should have written a program that makes the dx. I mean, what can I put in there? There is nothing else but x. So anyway. So when I press enter, I'm going to get some gibberish. And then I change it into a fraction because this is okay. And it's 10 over 9. Others, you will not be able to. And if the question is asking for an exact answer, you have to find it, please. Good, moving on. Let's do the cosine. That's my page 11. So this was, what is it, 33. The integral from pi over 2 to 0 from cosine theta d theta. Good. Which function prime is cosine? Which function I differentiate to get cosine? I know everyone knows which function we differentiate to get cosine. I have no doubt.
We just regular negative sign, right?
It's just sine.
Oh.
Sine prime is cosine. So from pi over 2 to 0. I plug in 0. What do I get when I plug in 0 in sine?
You get 0.
Exactly. Minus, don't forget the negative. When I plug in pi over 2, what do I get when I plug in pi over 2?
You get 1.
Exactly. And that's the answer. Can I check? Yes. I normally don't like to do this, but I just want you to be confident and check after you work on a problem. Not before. It makes no sense to just put in a number without the work. So here's pi divided by 2. And up here it's 0. And then we have cosine x, of course. Cosine x. Close the parenthesis, don't forget. And then the dx, of course. And when I click enter, I have to get negative 1. Good. Let's move on to other examples. Of course, it's still a polynomial. I have to distribute. Of course, there is no problem here because what is the procedure for this? 2 plus x squared over 1 term, the square root of x. What will be the procedure for that, for this problem? For 37. Anyone remembers what is the procedure for this type of problem? If it's a limit or if it's something else, or if it's a derivative, and also if it's an integral. We've done this before. Any? Yes?
Capital F of 1 minus capital F of 4.
We have to separate it into 2 fractions. We have to simplify. We don't know how to handle this.
Oh, yeah.
So for 2 plus x squared over the square root of x, we must simplify it as 2 over the square root of x plus x squared over the square root of x. And this is possible only because the denominator is one quantity. So this becomes 2x to negative 1/2. And this becomes x to 2 minus 1/2. 2 minus 1/2 is 3/2. And now this is a piece of cake for the integration, because you're adding 1 to the power and dividing by the result. You're adding 1 to the power and dividing by the result. So this is absolutely mandatory as the first step. And once I get here, the rest is easy. Is this better? Is this clear? Yes, is this okay?
Yeah, I get it.
Perfect. Questions for me? Do you feel like practicing more, or can we look at properties of definite integral? The definite integral has several
Can we
properties.
try?
Yes.
What
please.
about 38?
38? Absolutely.
Will we just multiply?
Oh
them?
yes, it's polynomial. yeah, you'll get 3u squared plus 3u minus 2u minus 2. You have to distribute
Okay.
first.
And
It's-
could we try something like
Any-
40?
Yes, of course. So in 40, this is one of the properties. You will see this in a minute. So from 5 to 5, from the square root of t squared plus sine t dt. Very good pick.
Wouldn't, if it's 5 to 5 and you're subtracting one for the other, isn't it always going to be 0?
Absolutely.
Ah, okay.
So this is the area under the graph, but there is no width. So this does not have a width because it's from 5 to 5. If it's from 5 to 6, it's a different story. But if these two limits are the same, the answer will always be 0. Oh, I'm sorry, you couldn't see. Sorry. So there is no width. So at 5, it's 5. The width is 0. So it's like delta x times f of xi, but this is 0. No matter what this is, 0 times this will be 0. Good. So we discovered already one of the properties. So let's see what else. How will you simplify this function before you start the integral? For 45. So what will you
To apply laws of exponents first to just simplify that?
How?
So, so you'd separate it, right? So it'd
Exactly. That's all I wanted to hear. I don't need to know anything else. Of course, you have to separate it into two fractions and simplify. Absolutely.